Hi everyone, in this video we're going to start talking about arc length. So this is basically a distance around the outside of a circle. So we're going to approach this the same way that we approached figuring out radians and degrees. We're going to look at what's going on with an entire circle, and then we're going to see how we can chop that up into smaller parts of a circle. So we're going to focus on, what do I have? Yep, this point P. And we're going to start with what happens if P rotates all the way around the outside of the circle. How far will it travel? And this again is something that we actually know for an entire circle. It travels around the circumference of the circle, and we know that circumference is 2 pi times the radius. And this was a circle with radius 3 inches. So we're going to have 2 pi multiplied by 3 inches, which is 6 pi inches. And then to find arc lengths on a smaller portion of the circle, we really just need to know what fraction of the circle that is. So just for a couple of examples, if we rotate through pi radians down here, then our point P travels halfway around the circle, which is half of 6 pi inches. So 3 pi inches. And then for pi over 4 radians, we could probably, easiest thing would be just to refer back to what happened with pi radians. But I want to compare this all to the whole circle because that's how we'll use our formula. So for pi over 4, I would say that's 1/8 of an entire circle. So we want 1/8 of 6 pi inches, which is 3/4 pi, or 3 pi over 4 inches. Okay, so this is really our strategy. The way we get to our formula, there's probably other ways, but the way I get to your formula is by looking at this as a proportion. So we know that whatever arc length we're going for, this little distance on the outside of the circle, it's going to be the same fraction of the entire circle, which is 2 pi r, as your angle theta is to an entire rotation, 2 pi. And then if we want this to be a formula for arc length, which s is our typical arc length variable, we're just going to solve for s, so we're going to multiply both sides by 2 pi r. Oh, my r's always look funny no matter what I do. 2 pi r. So s, we can cancel out the 2 pi, is theta multiplied by r, or more typically you'll see it s equals r theta. This is your arc length formula that we're going to be using. So I do have a link to a Desmos activity. This is more just so that you can play around with this and get a sense of if it's looking like what you would expect or not. So here it is. I'll show you a little bit. You can drag to change the angle, and if you watch over on the left-hand side, it tells you what your arc length is. So of course, as you increase the angle, your arc length increases. But you can also hold the angle steady and increase or decrease the radius and see how that increases or decreases the arc length. So I don't know if you need that. This might be something easy to visualize, but it's there for you if you want to play around a little and get a sense of it, or if you're working on a specific problem and you want to come look at that. Okay, where was I? Back into this one. And it looks like here is where I finally decided to put into my notes all this stuff about Greek alphabet letters, the Greek letter theta, and you'll also see alpha, beta, gamma, omega. So there's a link there if you want to see the entire Greek alphabet. Totally up to you. I don't know if that's interesting or not, but omega is a good one. I don't think I pointed that out earlier. Omega is something that we'll use when we talk about angular velocity a lot. So it looks like a little w, lowercase omega, but that's a really traditional variable to use as well. The only other thing I want to say here is this is a pretty simple formula. There's not much too tricky to using it, but there is one thing, so make sure you really make a note of the one thing. Theta has to be in radians. That's really important. The formula will totally fail if you don't do that. You can build a formula that has that conversion from radians to degrees in it, but my preferred method is to keep this formula that's a little easier to memorize and use that, and just always remember to convert theta to radians as needed. If you do forget the formula, hopefully it'll stick with you because it's not too hard, but you can always go back to this fraction of a circle business. So do try and keep that understanding in the back of your mind so that if you ever need to, you can recreate this. You could just go figure out what fraction of a circle your rotation is, and then take that fraction of the circumference. Okay, I think that's all I have here. Thanks for watching.